I'm going to talk about the logarithms of negative numbers. They are not real valued, and many college algebra courses leave them out. This is normally covered in graduate level courses called complex analysis, complex variables, or the like. But I'm going to show how this applies to college algebra level courses, 100 level algebra courses that involve the logarithmic equations. So here's some facts. Any negative number is a multiple of negative 1. So for instance, negative 2 is negative 2, or is negative 1 times 2. Negative 3 is negative 1 times 3, and so on. Okay? This property of logarithms is invariably introduced in college algebra courses. So for instance, log base 2 of 3x could be written as log base 2 of 3 plus log base 2 of x. Okay? This one is a change of base formula. Okay? Let's say log base 5 of 25 is going to be the natural log over natural log. You're taking the natural log of 25, and you're going to divide by the base you want to use. Okay? So, natural log of 25, I'll hit enter that in. I'm looking at 3.2188758, blah, blah, blah. Divide that by the natural log of 5, and I get 2. Well, that shouldn't surprise anybody because 5 squared is 25. Okay? This tells me what 5 to what power would give me 25. Okay? You have to use this formula. Some textbooks still show this. You can't use this for the logarithms of negative numbers. Only this formula is valid for this scenario. This formula. And finally, and this is what's new to us. The natural log of negative 1 is pi I. This is not normally included in college algebra courses, and as a review purposes, I is equivalent to the square root of negative 1. So let's get cranking. Natural log of negative 24 would be the natural log. Negative 24 can be written as the product of negative 1 and 24. Using this relationship, I can split this up, because this is log base c, natural log of negative 1 plus the natural log of positive 24. Natural log of negative 1 is pi I. This is just the natural log of 24. Okay, now, in complex numbers, the real component should be written first. The imaginary component should come second. Natural log of 24 plus the imaginary component, pi I. All right, but wouldn't it be nice if we could come up with a formula? Find a formula for natural log of negative k. Okay, so we'll go ahead and use it. We'll go ahead and set something like that up. Do natural log of negative k is equivalent to the natural log of negative 1 times k. And I could split this up into the natural log of negative 1 plus the natural log of k. The natural log of negative 1 is pi I, by definition. plus the natural log of k. So the natural log of negative k is equivalent to the natural log of positive k plus pi I. Like so. So, let's do an example 3, or an example 2. There's going to be an example 3 momentarily. The natural log of negative 26 would equal, erase the board and start over. Example 2, natural log of negative 26 is simply the natural log of positive 26 plus pi I. That's it. Okay? So let me go ahead and come up here. I'll copy this up here. Natural log of negative k equals the natural log of positive k plus pi I. Let's find a formula for log base b of negative k. We can do that. Okay? We have the information. Do log base b of negative k is equivalent to, we're going to use this formula right here, the natural log of negative k over the natural log of b. It follows from this rule. The natural log base b of your argument is natural log of the argument of the natural log of the base. The argument here is negative k, the base is b. And I showed you earlier how natural log of negative k is natural log of k actually, let me just go ahead and copy it over here. Natural log of negative k is natural log of positive k plus pi I over the natural log of b. Okay? I will then proceed to split the fraction. Natural log of b, or sorry, natural log of k. Natural log of k over natural log of b plus pi I over the natural log of b. I'm going to take this, I'm going to factor it out of there. Okay? So log base b of negative k equals the natural log of k over the natural log of b plus pi over the natural log of b times I. That's it. So So that's log base b of negative k is a natural log of k over the natural log of b plus pi over the natural log of b, and the I factored the I out of the numerator. All right, so here's example 3. Example 3, log base 5 of negative 25. Log base 5 of negative 25 equals the natural log of positive 25 over the natural log of 5 plus pi over the natural log of 5 times I. So, there's nothing I can do with this. That's going to stay as is. Pi over the natural log of 5 times I. But I can do something with this. Natural log of 25, hit enter, equal, is 3.2188758, blah, 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 divided by a natural log of 5. 2. All right. So now I want to apply this. Example 4. Find only valid solution to log base 3 of x plus 6 plus log base 3 of x plus 14 equals 2. Well, this is going to be log base 3 of their product going this way. So that'll be x plus 6, x plus 14, equals 2. So that'll be log base 3 of x squared plus 14x plus 6x plus 84 equals 2, which gives me log base 3 of x squared plus 20x plus 84 equals 2. I will dump the log, the 3 will go to the other side, the 2 will go up into the exponent. So the base 3 will go to the other side, the 2 will go in the 2 will go into the exponent. So I'll have x squared plus 20x plus 84 equals 3 squared. All right, I'm going to try to write that more legibly. Although the lower it gets, the harder it is for me to do that. So 3 squared and that's x squared plus 20x plus 84 equals 9. Equals 9. Subtract that 9. And I have x squared plus 20x plus 75 equals 0. So that'll give me x plus 5. So this will give me, this is solvable by factoring. The pair of factors is 75 out to 20 or 15 and 2. Or 5 and, sorry, not 15 and 2. I don't know where the 2 came from. 15 and 5. I must have been looking at that. So 15 and 5. So 5 and 15. Okay? Then I'll have x plus 5 equals 0. X plus 15 equals 0. Subtract 5, x equals negative 5. Subtract 15, x is negative 15. And these are both maybes because they both have to be checked. Okay? One of them is not going to work. Guaranteed. One of them will not work. All right. So I will check x equals negative 5. So I want to know if log base 3 of negative 5 plus 6 plus log base 3 of negative 5 plus 14 really does equal 2. Well, that's going to be log base 3 of 1. This is going to be log base 3 of 9. Well, first of all, they're logarithms of a positive number, so they are valid in the real number system. But let's go ahead and use the change of base formula to confirm what we should already suspect is that, and that is that both of these are valid. Okay? So, natural log of 1 is 0. Divided by natural log of 3 is still 0. Natural log of 9 is 2.1972245, so 2.19722, etc. Divided by natural log of 3. 2. Yep. 0 plus 2 is 2. So x equals negative 5. Okay, now the next question might be, what's wrong with negative 15? So now we'll check x equals negative 15. So it's log base 3 of negative 15 plus 9 plus log base 3, I'm sorry, negative 15 plus 6 plus log base 3 of negative 15 plus 14. All right, let me see how legible that is. If I move this over. Okay. All right, so this is going to be log base 3 of negative 9 plus log base 3 of negative 1. All right, so obviously these are not going to work in the real number system, but let me show you what they look like. Okay, let me show you what they look like, period. So this will be natural log, I'm going to use the change of base formula here. Actually, these are logs of negative numbers. So that's the appropriate formula. This would be the natural log of 9 over the natural log of 3, natural log of positive 9 over the natural log of positive 3, plus pi over the natural log of 3, natural log of 3, times the I, plus That should be negative 1. So that's going to be, following this rule, natural log of positive 1 over the natural log of 3 plus pi over the natural log of 3 times I. I want to know if it equals 2. Well, it sure doesn't look like it. Okay? It sure doesn't look like it, and I can tell you it doesn't. Okay? So here we go again. Natural log of positive 9. Natural log of positive 9, 2.1972, blah, 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 divided by natural log of 3. That's 2. Plus pi over the natural log of 3, because we can't do anything with this, plus the natural log of 1 is 0, divided by natural log of 3 is still 0, plus another pi, natural log of 3 times I, does it equal 2? Okay, so simplified, the real components, 2 plus 0 are 2, and these two combine into 2 pi of these. Pi plus pi is 2 pi. So 2 pi over the natural log of 3 times I does not equal 2. So the only valid, so this means that x does not equal negative 15. So only x equals negative 5 is valid. All right, and I hope that explains a great deal about advanced logarithmic equations.